Bonsuelo athletes, oh my, this is going to be a great day. We're going to talk about the graphs of functions. How do you look at something and know whether a graph is a function? The first thing we're going to talk about, which is that, how do you tell if a graph is a function or not? It should be pretty much cake. This right here, increasing, decreasing, and constant intervals. That will take concentration. We'll get to that one second. And you got to ask me questions. Okay, how do we determine if a graph is a function? We use what's called the vertical line test. You can read it there. Basically, the idea is this. You pass a vertical line through the graph. Why? Because along a vertical line, your x-coordinate stays constant. And then does the graph have more than one y-coordinate? In other words, does the vertical line touch the graph in more than one spot? Okay, so for instance here, does it ever touch it more than one spot? Okay, so here we pass a vertical line through it. Fine. At that value of x, we have a value of y there and a value of y there. So therefore, this does not fit the definition of a function. This is not a function because for that particular value of x, there is more than one value for y. So this is not a function. Okay? Let's move this up a little bit. So the answer to this one would be no. Okay, how about this one? Can you ever draw a vertical line that at any one time it's going to touch that graph more than once? No, every single one of these lines have a different x value. Each one gives exactly one y value, okay? So here, at this value of x, how many corresponding y values are there? Exactly one. At this value of x, how many corresponding y values are there? Exactly one. At this, is there any place you could draw a vertical line here and cross the graph twice? No. So this is a function. Okay, how about this? Well, take a look here. At that value of x, you have exactly one value for y. So far, so good. How about here? Okay, so this seems like it's a function, but is there any place on this graph that you can see that you could draw a vertical line and have more than one value for y? In other words, that you can touch the graph more than once? Yeah. As a matter of fact, there are a couple spots, but right here, you can touch it 3 times. Something's only a function if every single x value gives exactly one y value. And that's not true here. Some of them do give one y value, some of them don't. So this would not be a function. Okay. If you have any questions on that, ask me. That's not the hard part. Okay, here's the thing that you have to concentrate on. Okay, increasing, decreasing, and constant intervals. Okay. When you think of a graph, and I'm going to scribble some stuff here on the paper, don't write it down. When you think of increasing, what do you think of? It's going up. Good. When it's decreasing, what do you think? It's going down. Good. When it's constant, it's flat. Good. But like, what's going up? What's going down? What's flat? It's the y value, okay? The y value is getting bigger. The y value is getting smaller. The up and down variable is y. So for instance here, and I could have told you this before, but there's a reason why I've saved it till now, okay? All right. Where on an xy coordinate plane are your domain values positive? Well, over here, they're positive. The domain values, okay? In other words, on the right-hand side, your domain values are positive. Where are they negative? Well, over here. Your domain values are negative, okay? Now, you have to be careful here. Where are they 0? Domain is not 0 at the origin. Domain is 0 along the entire y value. Anywhere along the y value, along the y-axis, Your domain values are 0. Okay, well, that's domain. How about range? Okay. Your range values are positive on the top. Your range values are negative along the bottom. And along the entire x-axis, your range values are 0. Okay? Now, why do I mention this? When we think of increasing and decreasing, we think of up and down for the most part. Okay? Now, yeah, you can increase left and right, but most people, when you think of a graph going up, you think of it going, or a graph increasing, you think of it going up. Decreasing, you think of it going down. Being constant, you think of it as being flat. That's up and down. Okay, that's how you tell if something's increasing. Now, here's the hard part. What's the interval, though? What's the increasing interval, the decreasing interval, and the constant interval? It's the value of the domain over which the range is increasing, over which the graph is going up. It's the value of x, where the y value, or the entire graph, is going up. What's the increasing interval? The value of x, where the graph is going up, as we look at it from left to right. What's the decreasing interval? The value of x, where the y value, or the entire graph, is going down. And what's the constant interval? The interval of x, over which the range, or the y value, is constant. In other words, it's flat. Okay, so this is probably, I don't know if I can say this definitively, probably the most difficult concept we've had so far this year. It's not that the problems really themselves are that difficult if you understand the concept, but the concept is not easy, okay? Just remember, you're trying to find the value of x where the graph is going up, down, or flat, okay? This is where you need to use your pencil, okay? And you always need to keep your pencil vertical. Why? Because we're looking for values of x. All right? All right, let's take a look at an example here. Okay, where is this graph going up? Where is it going down? And where is it staying flat? First of all, you're going to get this wrong. Just right off the bat, you're going to get it wrong. And I'll tell you why. This is the thing that's going to kill you. Right here. The arrows. Okay? Ignore the arrows. They're going to mess you up. Because let's take a look at the first graph. And we're going to look at the first arrow. Is that graph going up or down? So problem number one, on the left-hand side, is the graph going up or down? Think about what you'd say, pause it if you need to think about it, but is that graph going up or down? Okay, I'm going to give you the answer. It's going down. Okay, why? What's an interval? An interval is always, of the domain, is left to right. Okay? Don't look at the arrow. It'll mess you up. It wouldn't be, if you can do it, if it's on paper, scribble out the arrow. It will help you, okay? I suggest you do this, like scribble out the arrow. Now, it's there. Don't, because if it's a dot there, okay? But I'm going to go back to putting the arrow back on. Okay, this is what you want to do. Out here, is that line touching the graph? Yeah, okay. So it started touching the graph out at negative infinity. The question is, at negative infinity, is the graph going up or down? Well, take a look at what happens as I go from left to right. Would you say these lines, as you go from left to right, follow the graph? is the graph going up or down? In other words, starting on the left, like put your pencil on the graph. I'm going to do it another way. Well, I'm going to finish this. Look at these lines. Notice they're intersecting the graph at lower and lower points. It's going down. Or if you want to do it another way, this would be maybe a better way to do it. And you're going to see me drawing a big fat line on it. Put your pencil on the left side of the graph and now follow the graph. Is that graph going up or down? It's going down. Let me do that again. I'm going to erase this. Okay, I'm putting it out here on the left, and then I'm going to go down. Sorry, I'm not going down. I'm just going to follow it to the right. So as you go from left to right, the graph is going down. Okay? So therefore, from negative infinity to what? Where does it stop going down? It stops going down right there. So from negative infinity to negative 4, it is decreasing. Again, I can't emphasize enough that you ask me questions on this if you've got questions on it. Now, I'm going to just mention something that's a very fine point. I'm not going to try and explain it right now. I'll explain it at the end. You never put brackets on increasing and decreasing intervals. Everything is always parentheses, and I'll explain why at the end. Okay, so let me get rid of this part of it. But if you have questions on it, ask me. Okay, so now let's see what happens again as I'm going. Okay, that's flat. It's not going up or down. So from negative 4 to, what is that? 1, 2, 3. It's a constant interval. And now again, ignore that arrow. What's the graph doing from 3 on? Well, it's going down, okay? But let me show you something. This is what a lot of people put. They put from 3 to what? Is that to negative infinity or positive infinity? Think about it for a second, and then I'll tell you. Pause the video if you need to think about it. That's going to positive infinity. Why? Because remember, we're looking at x values, and going out to the right is positive infinity. You have to be very careful not to look at those arrows, okay? This graph is never going up as we look at it from left to right. At no point is it ever going up. It's going down from here to here, and it's going down from here to here. And that is negative infinity to negative 4, and then 3 to positive infinity. The x value is positive infinity. And then the constant is from negative 4 to 3. That's not that hard. But the thing that's weird, well, there are a couple things weird about this, but all I can recommend is ignore the arrows as much as you can. If it's on paper, scribble them out or something, but ignore the arrows. They'll kill you every time. Okay? All right, I'm going to move on. And again, we could write this as an inequality, and if someone wants me to do that, you can come and see me, but I don't want to, believe me, it's much easier to do this. Well, actually, I've told you to write them as intervals, so in this case, you couldn't do them as inequalities. But if you want to know what they'd be as inequalities, if the instructions didn't say an interval, just see me and I'll tell you. Okay, let's take a look at this. Again, what is this graph doing out on the left? Is it going up or down? It's going up. Whoa, why did this do this? Okay. That's going up. All right. So it's from negative infinity. Why is it negative infinity? Because out here is negative infinity, not because the arrow is pointing down. It has nothing to do with that. Okay, so this graph is going up from negative infinity to, what is that? 1, 2, 3, 4, 5, negative 5. And again, you always use parentheses for these. I'll explain why at the very end, but that's kind of a fine point. You can either just memorize that it's always parentheses, which is fine. But I'll explain it at the end, but I don't want to dwell on that right now. Okay, then what happens at negative 5? Now the graph is going down. Okay. But where does it go down to? Remember, you're looking at the x value. It goes down. It doesn't go down to negative 3. Okay? So it's going to go from negative 5 to an x value of negative 1. And then what's the graph doing? Starting up again at negative 1, the graph's going to go up. To what x value? Positive 5. And then from 5 up, again, yes, the graph is going down, but your x values are going up. That's the hard part. You're finding the values of x where the graph, your y values are going up or down. Okay, and then there's no place where this thing's constant. Okay, I'm going to erase this and kind of, if you want to back it up, you may and listen to it again, but I kind of want to leave it blank for you to kind of look at it yourself. Okay, let's take a look at this last, and so there's no constant interval here. Okay, let's take a look at this last one. Okay, is the graph touching that line? Again, you want to use moving your pencil across it. Yes, it is. Is the graph going up or down? Don't look at the arrow. The graph is going up. The graph is still going up. The graph is still going up. Has it ever flattened out or turned around and gone down? No. This is, so number 3, the graph is increasing from negative infinity to positive infinity. Okay? It has no decreasing or constant interval. It's always going up. Again, one thing you can do is take another thing, but you got to be careful with this when I tell you to do this. If you just want to know if it's going up or down, you can take your pencil and run it along the graph. But if you just do that, you're running the risk of giving me the y values instead of giving me the x values. That's why I suggest you use a vertical line to figure out what the x values are. Okay? And I think I'll leave it at that, with the exception of maybe trying to describe to you why you always use parentheses. Okay? So this is not that big of a deal. If you just want to memorize, you always use parentheses, that's fine with me. But it's good to know. So I'll give you an idea. All right, let's take a look at problem number 2. All right. Okay, and I'll just take like kind of the middle of the graph. Here, what's the graph doing? It's going down, and it goes down to right there. Okay, then what's the graph do? It turns around and goes back up. So over here, it's going down. Over here, it's going up. Well, at what point did it stop going down and going up and start going up? Right here. Okay, now I'm going to erase all this so you can see the graph a little more clearly. But that's the point at which it stops going down and starts going up. Okay. Okay, well, what I want to know, there's the point I was talking about. What I want to know is the graph going up or down at that point? Okay? In other words, we have something that looks like this. I'll kind of sketch it underneath. Right here, the bottom, what's the graph doing? Well, you could say it's going down because on this part of it over here, it's going down. Okay, maybe that must be going down then. But how about over here? That point's also on this, and it's going up. Well, okay, it's going up then. Well, how can that point be both going up and going down? It can't. Okay? The point that's in the middle, it's neither going up nor going down. It's actually just kind of there. I don't know. I don't want to call it a constant because you need more than one point to have something be constant. But that point is neither going up nor going down. Why? Because right here, right there, it's going down because of the part of it that's on, because the left of it's going down? Well, no, because the part on the right is going up. So that point is neither going up nor down. And there is another way I can explain it, but it might make it a little too confusing. So if at this point, if you don't like this, you have my permission to stop listening. Okay, but I'm going to draw something else down here. Okay, in order for a graph to be said to be going up, or a point to be said to be on the part of the graph that's going up, you have to have, let's say, if I want to say that point is on the part of the graph that's going up, there has to be one point on the left that's lower than it and a point on the right that's higher than it. That's the only way I can say that this point is on the part of the graph that's going up. Okay? And consequently, if I want to say that point is on the part of the graph that's going down, on the left side, there's got to be a point above it, and on the right side, there's got to be a point below it for that point to be said to be on the part of the graph that's going down. Well, let's go back, and if you don't like this again, don't worry about it. This is not that big of a deal. Let's take a look at that point, okay? That point right there. Well, on the left, it's got a point that's higher than it. Okay, that's good. But on the right, there isn't a point that's lower than it. So I can't say that point's on a graph going down. Okay, well, maybe it's on the graph going up. Well, on the left, it doesn't have a point lower than it. Yeah, okay, on the right, it has a point higher than it. But, I can't say it's on the graph going up. So that point is neither on the going up part or on the going down part. That's why you put a parentheses. Again, if you don't like that, go ahead and just memorize that you put parentheses, but you put parentheses. Do not put a bracket for increasing and decreasing intervals. Everything else, you have to figure out whether it's parentheses or a bracket. Domain, range, everything else, you've got to figure out whether it's parentheses or bracket. But for increasing, decreasing, and constant intervals, you never put a bracket. That's a tough one, okay? Might take a few times listening to it, but again, don't just listen to it over and over again. That's not what I want you to do. Yeah, I do want you to listen to it, back it up, listen to small parts of it again. But, after you've really given it your best shot, you just got to come and talk to me. I got to ask you to do something, show me what you're doing, and then we can go from there. Okay? And that's what I want to do. That's what I want you to do. So that ends section 2.1. Gosh, that's only one section in this whole chapter. Doesn't this just kind of give you the idea that this chapter is going to be filled with fun topic after fun topic? I hope so. Have a good day, everybody.